Welcome to Study Loop.
For this problem on the topic of waves and sound, we are given a diagram which shows a microphone located at the origin, we'll call microphone 1, and a second microphone, microphone 2, located on the positive y-axis. They are separated by a distance d, which is given, and we have a source of sound which is located on the positive x-axis as shown in the diagram. So the distance of the sound source from microphone 1 is L1, and the distance from microphone 2 is L2. We're given the speed of sound, and we're told that the sound reaches microphone 1 first, and at a given time later reaches microphone 2, and asked to find the distances L1 and L2. Now, the sound reaches the microphones at different times because the distances between the microphones and the source of sound are different. And since sound travels at a constant speed of 343 meters per second and arrives at microphone 2 later by an interval we'll call delta t, and delta t is 1.46 milliseconds, or 1.46 times 10 to the minus 3 seconds. And it follows from here that L2 minus L1 is equal to the speed of sound v times delta t, and we'll call this expression 1. Now, next, the microphones and the source of sound are located at the corners of a right triangle, and therefore applying the Pythagorean theorem, we get that L2 squared is equal to d squared plus L1 squared. So this is from Pythagoras. We'll call this equation 2. Now, v, delta t, and d are known, and we can solve these two equations simultaneously to find L1 and L2. So let's find or rewrite equation 1. So we can solve equation 1 for L2, and we can write L2 as L1 plus v delta t. We can then substitute this into equation 2. And this gives us L1 plus v delta t all squared is equal to d squared plus L1 squared. So if we simplify this, we get 2 into L1 v delta t plus v delta t all squared is equal to d squared. And from here, we can solve for L1. So we essentially have one equation with one unknown. So we get L1 to be d squared minus v delta t all squared over 2v delta t. And all of these values are known, so we can find L1. So we know d is 1.5 meters, and that's squared, minus v, which is 343 meters per second, the speed of sound, squared, times the time delay delta t squared, which is 1.46 times 10 to the minus 3 seconds all squared, divided by 2v delta t. So that's 2 times the speed of sound, 343 meters per second, times delta t, 1.46 times 10 to the minus 3 seconds. And so we get L1, if we compute this, to be 2 meters. Now that we have L1, we can go to equation 2 and find L2. So if we solve 2 for L2 and substituting the result for L1, we get L2 is equal to the square root of d squared plus L1 squared, which is the square root of 1.46 5 meters squared plus L1, which we calculated to be 2 meters squared, we get the distance L2 to be 2.5 meters. And so we've calculated for L1 and L2.